All right. So we're in a section called analytic trigonometry. Basically, it's like the algebra side of trigonometry. Okay, it's the algebra side. There's not much graphing. There's not much shape. It's just like all the figuring stuff out and stuff. We're going to spend a lot of our time on these things called identities. We'll kind of see what those are as we go. But identities are really useful for simplifying expressions and also for solving equations. So that's why we're spending so much time on it. This chapter, it's been, in my experience, the notorious chapter where it's kind of challenging. So I'm actually not going to give you guys one big test. I'm going to give you two little tests because I feel like it could be overwhelming if I did that in the past. That's helped students a lot. So actually, I anticipate, if things go according to plan, actually having your test, the first test next week on Monday. Okay? And then we'll do the second half of chapter 12 after that. So that's the plan. Let's go ahead and jump in here. So we're going to be talking about these things called identities. Oh, you just grab the part. Cool. We're going to be talking about these things called identities. So what is an identity? An identity is an expression that is equivalent or identical to another expression. So for instance, you could say that 2 parentheses x minus 1 is oh, you guys can't even see it? Sorry about that. I'll wait a second for you. So I'll just kind of start over there. An identity is two expressions that actually are the same, even though they're written differently. Okay, so I've gotten that example there. I wonder if there's another example here. Yeah. So like, for instance, x squared plus 2x plus 1, if you factor it, it looks like this. Well, they look different, but they're identical in value. Okay, so that's essentially what an identity is. All right, so what are identities used for? They're used for simplifying expressions. So, for example, if you have x squared plus 2x plus 1 over x plus 1, if you factor that top there, you can reduce and end up with something simpler. So that's one thing that identities are useful for. If you can rewrite an expression with something else, it might make it easier to rewrite it somehow. Okay. All right, so that's one thing they can be used for. They can also be used for solving equations. So like, you guys know that we've used factoring to solve expressions like this, right? So that's why we use identities. For the first half of chapter 12, we're going to be doing the first thing, just learning how to simplify expressions with them. For the second half, we'll be using them to solve. Now, what I've given you guys here is just standard algebra examples. We're going to be doing this stuff with trig, though. So you don't need to write this. I printed this one for you. These are some identities that you're already aware of in trigonometry. You guys know that sine and cosecant are reciprocals of each other, right? You know that cosine and secant are reciprocals of each other. And tangent and cotangent are reciprocals of each other. And those are what we call the cotangent identities. I'm sorry, the reciprocal identities. Here's some that you might not have known about. I'm not sure or not, but these are called the quotient identities. Tangent is sine over cosine, and cotangent is cosine over sine. Okay? So I'll just kind of prove this for you guys really quick. Why is tangent equal to sine over cosine? Okay. Well, let's go back to our unit circle for a minute here. So let's say I have an angle here. Remember how we drew triangles? The height represents the y value, the length represents the x value. Right? And tangent. You guys remember what tangent is? Tangent is what over what? Opposite over adjacent, right? I shouldn't put x there. Let me undo that for a second. So tangent of that angle would be opposite. Oh, I went too far. Put it back. Opposite is y, adjacent is x, right? But we also learned that y is the same thing as sine, right? And x is cosine. So tangent is actually sine over cosine. Okay? And you can use a similar process of proof to show that cotangent is adjacent over opposite, right? So that would be cosine over sine. All right? Okay. So now we're going to actually put these things to work for us. We've learned two different types of identities, quotient and reciprocal identities. I'm going to show you how we can use those to simplify an expression or verify an identity. I'll explain what that means in a minute. Go ahead and copy this down. All right, guys. So a couple of things before we begin. It says prove that this equals this. That's our goal. I want to prove that this side on the left is the same thing as that. And the way I'm going to do that is I'm going to rewrite a lot of things until the two sides look identical. Okay? So that's the goal. Now you might also see the word verify. That's the same thing as prove. So if you guys see the word verify, what we're going to do is we're going to be verifying that the two sides are actually equal to each other. And we're going to do that using identities. Now, the only reason why I give you problems like this where we're verifying is because it gives you a starting point and an ending point. We know what it looks like, and we want to turn it into this side, basically. But like I said, usually it's just the point is to simplify or solve an equation, but we're just practicing with all these identities we're using. We're going to practice how we can use them to rewrite things. Now I'm going to be giving you guys three different strategies, and I don't know if we'll get through all three today. But the first strategy I'm giving you is changing everything into sine and cosine. That's strategy number one. Okay. Strategy number two is simplifying complex fractions. You'll see that we're going to have fractions inside of fractions, and how we deal with that. All right, that's another one. And then strategy number three is combining fractions. So if you see like two fractions being added together, we'll probably want to add them together. So those are the three types of algebraic strategies I'm going to share with you so that we can learn how to rewrite these expressions. So we'll go ahead and do the first one here. All right, so it says rewrite everything as sine and cosine. All right, so before we begin, I want to focus on this too a little bit. Little note you might want to write to yourself is that this means this. Okay? Whenever you square a trig function, a trig ratio, you put the square after the trig ratio. You don't put it after the variable. The reason you don't do that is because that makes it look like this. Like what we mean, don't write this part, but what we mean to say is we're squaring the whole thing, secant x. But you don't want to write it like that because this means secant of x squared, and that's something different. Okay? So here we're taking the secant of x squared. Over here we're taking the secant of x, and whatever that is, we're squaring it. Those are different things. So what we do in trigonometry then is we put the square next to the trig ratio, and what that means is we're squaring the whole thing. Now, I'm going to just be rewriting it myself, but you don't have to. If to you that's just obvious and you don't need to rewrite it, then that's fine. All right, so the first thing I'm going to do is I'm going to rewrite it. It just looks more friendly to some of us that way. Okay. Now we're going to start changing everything into sine and cosine. So bless you. I only want to see sine and cosine. I don't want to see nothing else. So give me one thing up here that's not a sine or a cosine. The cotangent. All right. So what I want you guys to do is I want you to look at that sheet that I gave you that has all the list of the identities, and I want you guys to find out of those top two areas which one allows me to rewrite cotangent as cosine or sine. It's cosine over sine. Now you guys do see the other one, right? You see where it says cotangent is 1 over tangent x? You can use that, but honestly, I would probably just put an x through that one because we'll probably never rewrite something as tangent, and we'll probably never rewrite something as cotangent. We're almost always going to rewrite them as sine cosine. You can do those things. It's just that, in my experience, this is the most useful thing to do. So the first thing I'm going to do is I'm going to rewrite cotangent as cosine over sine. And that is a quotient identity, right? What else is not a sine or a cosine up here? Secant. So what would I rewrite that as? Take a look at your sheet. Those first two boxes, I can rewrite secant as what? Cosine. Yep. Secant is 1 over cosine, right? Just for the heck of it, I'm going to go ahead and make this a fraction just so it matches all the other ones too, by the way. And we can also do cosecant. Cosecant is also, can be rewritten as what? 1 over sine. Okay. Now, I'm going to get rid of this square here, so I'm going to square the 1 and square the cosine. So that's going to be 1 over cosine squared. And then I've got cosine x over sine x, and then cosine x over 1 and 1 over sine x. All right. Now let's go ahead and simplify this. What is, hello. Yeah, I'll give it to her, thank you. What is 1 times cosine going to be? Good. Cosine x squared, right? If I multiply all the way across on the top, that's what I get. And what is cosine of x squared times sine times 1? That's going to be cosine of x squared sine x, right? We don't really need the 1, right? 1 doesn't really do anything. I'm running out of space, so I have to erase some stuff. All right, and then on the right side, we still have 1 over sine x. What do you guys see what we can do here? You can take both of those out because they're both squared, right? And I'm left with what on top? 1 over sine x equals 1 over sine x. As soon as I got those two sides looking exactly the same, I have proven what I wanted to prove. Remember, my goal was to prove that this side equals this side. So by doing those identities, I got them to be identical. That's the goal. Okay? So what did I do? Just to kind of review with you guys a little bit. First of all, I rewrote that, right? I didn't like the square there. You don't have to if you don't want to. And then I used the quotient or reciprocal identities to change everything into a sine or cosine, put it all together, and by the time you reduce, you should end up with two sides that look exactly the same. Okay? So that is strategy 1. So I'm going to go ahead and throw one at you here. Let you guys practice that. I would like you guys to do number 1 up here where it says student. All right. Let's go ahead and go over it here. All right, so PJ, what did you do first?
Changed it to sine and cosine.
Okay, changed what into sine and cosine?
Secant.
Okay.
I mean the tangent.
Okay. So tangent. Now looking at your guys' sheet there, you guys find the one that what tangent equals. Tangent is equal to sine over cosine, right? So we're going to replace this tangent with sine over cosine. Next we'll ask Najib, do I change cosine squared? No, it's already a cosine, so we're going to leave it alone. I'm going to go ahead and write it as cosine like that, but you don't have to if that's unnecessary for you. Amanda, do I change secant? What do I change that into? 1 over cosine. And then Iman, do I change sine? No, we'll leave that one alone. You can put it over 1 if you want to. That's kind of unnecessary as well. But, all right, so let's go ahead and move on to the next one. Justin, if I multiply straight across here, what do I end up with on the top altogether?
Sin x.
So we have sine x and then cosine squared x, and the times 1 we don't need, right? All right. And how about Melanie? What do we get if we do cosine x times cosine x? No, when you square something like, what's x times x, for instance? Right, so cosine x times cosine x will be, you got it, good. So there's that. We're almost there. Jalissa, what's next? And one more question going to Tavier. How do I know I'm done, Tavier?
They're equal to each other.
They're exactly the same. We're done. We proved that that side is equal to that side using the identity. So that's kind of the goal. That's strategy 1. Okay? All right, so we're going to move on to another strategy. How you guys feeling? Do you feel like you should practice another one of these types before we move on to another strategy? Or do you feel like you got this? So let me ask, how many of you guys feel like you're ready for the next strategy? Throw up in here. Okay. All right, we'll move on. The reason I was asked is because it started off a little slow at first, but then you guys jumped on, and as I came around, everybody was doing pretty good. So I wasn't sure if you guys wanted to try again or not. But all right, let's go ahead and move on to another strategy. Write down this one, please. Okay, I'm going to switch slides here so I can have a little bit more room. Let me know if I'm not writing this right. Is that it?
Yes.
All right. So before I begin our new strategy, I'm just going to simplify the right side. What do you guys think I'm going to do on the right side? Starts with a D. Distribute. Okay. I know it looks weird because usually we distribute numbers, but you can distribute these as well. So what is sine x times sine x? And I write mine like this, but if you want, you could put the square there after the sign as well, but don't just put it next to the x with no parentheses. And then sine x times 1 is just going to be sine x, right? Anything times 1 is just itself. All right, so that's not a strategy I'm sharing with you. It's just something that we kind of need to do along the way. But over here on the right side, the first thing I'm going to do is I'm going to I'll write what I did here. On this side, I'm going to change everything to sine or cosine. You're going to want to do that pretty much every time. All right, so over here on this side, cosecant. That's not what I want, right? I want sine or cosine. So look at your identity worksheet there. Cosecant is what?
1 over sine.
It's 1 over sine. So I'm going to replace cosecant with 1 over sine. I feel like I should have done this first. I'm going to rewrite this now so it looks like this. Is that okay with you guys? Okay. And so what this is going to become now is 1 over sine of x squared, right? So there we go. We good? Uh-huh.
So if it's a reciprocal of it, then why
Yeah.
wouldn't it be?
Wouldn't it be split?
Yeah. So if we had cosecant on the bottom, cosecant on top, wouldn't it be sine? Wouldn't it be
On top.
because cosecant on the bottom is effectively 1 over the
You're right.
so flip.
You're right.
So would it
You're right. So you can do that. I don't know if I want to teach it that way, but you're right. So I'll tell you guys what Cameron's saying. He's saying that since cosecant's on the bottom, isn't that basically 1 over cosecant? So then basically can't we just cross this off and put sine squared on the top? And the answer is yes. I don't know if that's going to click with a lot of people, but if that clicks with you, go for it. It works, absolutely. So, but the way I'm just going to stick to teaching it is basically find the trig piece that you want to replace and replace it. That's how I'm going to do it. So since cosecant is equal to 1 over sine, I'm just going to replace cosecant with 1 over sine. But yes, what you said will work. All right, now I'm going to go ahead and do this. You're going to square this. You're going to square the top and the bottom. So that's going to be 1 over sine x plus 1 over 1 squared is 1, and sine squared is going to be that. Okay? Oh, and the right side is not going to be changing. I'm just going to leave it as is. So far, guys, believe it or not, I'm spending a lot of time on this, but we really haven't employed the new strategy yet at all, right? All I've done is distribute. That's not really new to us. And I've rewritten cosecant as 1 over sine, which was our first strategy we learned. So now I'm ready to share with you the new strategies. And it's really, even that's not a new strategy. But the strategy that I'm labeling it is simplify the complex fraction. Okay? So I don't know if you guys remember this, but when you have fractions and fractions, what we talked about is you want to multiply everything by these little denominators. That's kind of ring a bell a little bit. All right, and I shared with you guys that the best way to do it is to do it with the biggest one first. So what's bigger, sine x or sine squared? Sine squared is bigger, right? So what I'm going to do is I'm going to multiply everything by sine squared over 1. Oops, I'm being inconsistent here. I could write this one as over 1 if you want to, but since 1's not a fraction, I'm just going to leave it as sine squared. Okay, so this is the strategy here. Simplify the complex fraction. All right, so on the bottom here, notice that these are exactly the same, so they cancel, right? And there's nothing left down there. So I'll put a 1, but we don't really need to. Sine squared x times 1 is just going to be sine of x squared there. How about over here, though? What's sine of x squared over sine of x?
Sine of x.
Is sine of x, right? Just like if you had x squared over x, the x on the bottom takes 1 away on the top. Well, if you have two sines on the top and one on the bottom, this sine will take 1 away from that. So now we're just left with sine of x. And do you guys kind of see we're already kind of done? Yeah, Tanya. Good question. I'll get to that. She asked a really good question. We'll get to that. Yeah.
Where did the sine x squared come again?
Which one?
The one that we multiplied everything by?
So you find the little denominators like these guys here. You know, you have a giant fraction and there's little fractions inside of it. So the little denominators, you multiply everything by the little denominator, basically.
How come you chose the one with that square?
It's better to pick the one that's bigger. So sine squared is bigger than just sine. It'll cancel more stuff. But you could have done the sine, but you would have to do it again after that. All right, so a little bit of, I mean, now this is, I would take this as your final answer. This is actually good enough. But, you know, just to make it look really nice, we don't need the one on the bottom right. And we can also reverse these because with addition, the order doesn't matter. Can't do that with subtraction, but with addition, you can. You can reverse these. So now they look exactly the same. And we're good. Okay, so there's a lot going on here, but what I really want you guys to understand is this step here. That's the new strategy there, is where you multiply everything by the little denominators to simplify the complex fraction. That's the big one. Okay, the rest of it's just kind of little details along the way. All right, so here's one for you guys. Why don't you guys try number 2? I'll kind of walk you guys through it a little bit with words, but I'm going to let you guys do most of the work.
Just cancel the fact we did it. It won't be fair for one of us.